Greetings, everyone. We're going to be looking at the solutions for Module 2 for numbers 21 to 27. So let me share my Excel screen so we can work through these problems. They've been indicated that you don't need to use Excel for this, but I will be doing it on a spreadsheet and I'll be using my pen to write. So you could see how you could also do this on on paper using pencil. All right, so let me share my screen with you guys and let's do this. All right, let's start with number 21. It's giving you a normally distributed experiment, and obviously it has to be because if they're asking you any empirical rule questions, it requires the distribution to be normally distributed. It says the mean is 100 for the entire population, so the IQ of the entire college, so I assume it's population, even though it doesn't really matter. For z-scores, whether you have a population or sample, the formula makes no difference. Let me insert, instead of saying population mean, I'm just going to insert a symbol mu, and I can find it on insert. All right. And then the next one is the standard deviation, which is sigma. So I think I have a symbol for that too, if I can find it. Let's see. Probably not. Should be somewhere in these symbols. Let me see. We're looking for alpha. There we go. All right. Sorry, sigma. Oops. If I can find it. It has to be here. There we go. That's sigma. All right. So the mean is 100. Standard deviation is 15. And it says what percentage of college students are between 70 and 130. So, for empirical rule, one standard deviation away from the average is 67, 68. Two standard deviations is 95. Three standard deviations is 99.7. So all you have to figure out is how many standard deviations 70 and 130 are away from the average, which is 100 in terms of 15, right? So basically what I'm trying to say is if this is your normal distribution, and if this is your average is 100. Now it says between 70 and 130. So all you have to do is to try to figure out how many 15s is 70 and 130 away from 100. So it's like 130 it looks like two 15s, right? So if you go 115 and another 15, that'll take 100 to 130. And if you go 215 units to the left, and each 15 unit happens to be one standard deviation. So basically you've gone two standard deviations here to the right, and here you've gone two standard deviations to the left, which brings you to 70. All right, so in order for you to capture 70 to 130, you have to go two standard deviations away from the average, which based on the empirical rule says you have captured 95% of the population. And that's why I said you really don't need to do this problem on a spreadsheet. So, and that's literally what I meant. And that's the answer to question number 21. The answer is 95%. All right, let's move to 22. Same kind of problem, but this time it says the average GPA is 2.9 and the standard deviation is 0.6. So instead of 115, now we have 2.9 and 0.6. So here mu is 2.9. If I go to insert to make it actually write the symbol mu, insert, and close it, and then sigma, population standard deviation. All right, so the mean is 2.9. Standard deviation is 0.6. And I'm trying to figure out what percentage is between 2.3 and 3.5, which means, again, what you need to figure out is if you draw the normal distribution, and I know the average is 2.9, so it's right in the middle. So again, the question is, how many standard deviations is 2.3 and 3.5 away from 2.9? Now, mind you that each standard deviation is 0.6 units. So how far is 3.5 away from 2.9 based on 0.6 being my units of measurement? Well, 3.5 seems to be 1.6 away from 2.9 because 2.9 plus 0.6 is 3.5. So this looks like only one of them. And if I go one standard deviation to the other side, I will capture the left-hand point, which is 2.3. So if I go one standard deviation to the left, 2.9 minus 0.6 is 2.3. And that's how you could actually capture the empirical distribution rule here. And that's 2.3. So it basically tells you that 2.3 and 3.5 happen to be one standard deviation away from the average. Now, let's see if you remember the empirical rule at this point. The empirical rule says that if you're one standard deviation away from the average, you have captured 68% of the population. So the answer here would simply be 68%. Okay, let's move on to the next one. It's pretty much the same problem. Number 21, 22, same thing. I'm just using a different example. All right, what does this one say? This one wants us to figure out if it's usual or unusual. Anytime they ask you for usual, unusual, and I give you the hint, but I may not give you that hint on a test, and that is anytime they ask you for usual, unusual, always remember to find the z-score. And we know that if you find the z-score, and if it happens to be between -2 and 2, then you call the data value usual. And if the z-score is below -2 and above 2, then it's called unusual. So if I draw a grid here and put -2 and 2, this part will be usual, and this part will be unusual. So basically, all you have to figure out here is the z-score for the data value you're looking for. And if that z-score happens to be a value between -2 and 2, then you conclude that it's usual. If it happens to be a z-score that's less than -2 and greater than 2, then it would be unusual. Well, let's see. It says determine the gasoline price at 3.12. So here, the value I'm trying to determine whether it's usual or unusual is 3.12. Right? So that's the value I'm trying to determine, its usualness. All right, so let's see. Well, obviously, if I want to find a z-score for some value, I have to have been given the mean and the standard deviation, because the z-score by definition is x minus the mean divided by standard deviation. And I didn't want to write mu or x bar because it doesn't really matter, because whether it's a population or is a sample, the formula to find the z-score is the same. So it doesn't really matter if you have the population mean or the sample mean or the population standard deviation or the sample standard deviation. Either way, you get the same z-score. So for z, it doesn't make a difference. All right, so let's see the mean of this population. And again, let's just do it professional. So there's my mean. And let's insert the standard deviation as well. There's the standard deviation. All right, it says mean price is 3.05, so 3.05 is the average. And what's the standard deviation? 0.5. All right, so basically it says the usual or unusual. It says hint, find the z-score. Now, how would I find the z-score? So here you would use a little bit of Excel, open parentheses, x, and I don't really have to type x, just click on it, minus the mean, which is that, close parentheses, divide by the standard deviation. So the z-score is like 0.14, it's like close to 0. So it's obviously between -2 and 2. So therefore, this is a usual value. So the value of $3.12 for gasoline is a usual value because its z-score is between -2 and 2. It's basically close to 0 for this case. And again, you do number 24 the same way. So if I copy these 3 letters here, so I don't have to type them again. There we go. Here, my X happens to be, let's see, is it usual $118.94, $118.94. Make that column a little wider so you could see the numbers. All right, my average here is mu 106, and my standard deviation is 5. And again, it wants us to find the z-score, and you know how to find the z-score. It's x minus mu, close parentheses, divided by sigma, always. And here, you notice that the z-score is 2.59, which basically means it falls outside the plus minus 2 standard deviation. So which means it is, you guessed it right, it's unusual. And that's number 24. Moving on to number 25. They've given me a bunch of numbers here. They're asking me to find the 36th percentile, and it's asking me to do the EXC calculations. This is pretty simple. 36th percentile, 36th, best way I can write it on Excel. Literally, the way you write the 36th percentile mathematically will be P subscript 36. That's how you read 36th percentile. Okay, but how it's calculated, it's pretty simple. Let me share the cell so I could comfortably type percentile, and I said use the EXC extension, so I'll use the first one. It says select the numbers, okay, whatever you say, comma, and it says what is the 36th percentile? So 0.36. I think in the uploaded exercise here, I was asking for like the 5th or 6th percentile or something, and it ends up being 0. So, and that nothing wrong with that because a lot of zeros in a data set, but that could be confusing if you're calculating this first time. So that's why I've changed it to 36th percentile so that you actually get a value. And let's see, yes, 2.04. If you were to find like the 5th percentile, this would have been, again, you would have typed percentile, and let's say 5th would have been 0.05. Oh, sorry, first I have to select that. Here it says select the numbers, don't forget, and then comma. Now you say 5th percentile, which is 0.05. Let's see what that will be. Yep, that's 0. Let's see the 11th percentile. P11. So let's see the command for 11 percentile, see what that would be. Select the numbers. 11th percentile is 0.11. Still 0. So here in this set of numbers, lower percentiles are pretty much 0 because all the numbers below it, like the below 5%, are all zeros anyways. That's why it just says 0. So don't panic if you get a 0 for the answer if it's a small percentile. And if you calculate the 36th percentile, you should get a 2.04. All right, let's move on to number 26. Now, number 27, just so you know, guys, there was a typo on C, so I fixed it. I'll calculate it. It pretty much asks you to find a z-score. The mean is 3.77. The standard deviation is 3.99. And it says which one of these is a proper z-score for a value of 6.19. So doing this problem before I do the one before it, if I copy the 3 values we need to calculate the z-score, and then I come back here and copy them here. All right, the x value in which I'm trying to find a z-score for is 6.19. My mean is the mean of this at 3.77, and the standard deviation is 3.99. Now, just so you know, this doesn't say population and sample, so you could say mean and standard deviation, because you really don't know if it's x bar or mu. And thank God for z calculations, doesn't really matter. So open parentheses, x minus mu, divide by sigma. And it's 0.67 if you round it, 0.61, so it's B, 0.61. Excellent. Let's move on to number 26. All right, guys, let's look at number 26 now. All right. So let me just move this away so we can comfortably have a conversation about number 26. Again, as I said here, number 26 is a problem that foreshadows module 5, and I think I spelled module wrong, no? Module. All right. So it foreshadows module 5, but nevertheless, it's a good idea to pick it up early on, at least look at it visually. At the end of module 2, I teach you guys how to calculate percentiles using the percentile command, and it's right here, and I've already shown you the command. So that's a percentile command, and you can have an EXC and INC depending on what the instruction is. So if you have a bunch of numbers and I ask you for a particular percentile, everybody could find it by simply typing that command. The important thing is, what does it mean to say that, let's say the 20th percentile is 48? That's the question. Pictorially, if I say the 20th percentile of a data set is number 48, what does that mean in terms of the normal distribution? Now remember, all of these assumes bell-shaped curve. So the question for number 26 is for my students to actually pictorially understand what it means for the 20th percentile of a data set to be 48, given that the average is 73, right? Assuming there's the final exam scores. Now, the best way to see it is by looking at a drawing of the normal distribution, which I'll do. So let me draw the distribution. Right? The average is 73, so average always in the middle of a normal distribution. And now it says the 20th percentile is 48. Now, if 73 is in the middle, and this is the score line, or the score axes, if that's 73, where do you think the score of 48 would be? Yeah, obviously to its left, because left go down, right go up. For like, this is like 92 or something. All right, and this is like 4. Right, so that's how it oscillates. Anyway, so the test score of 48, that's the 20th percentile. This number here is the 20th percentile. Okay, we get that, but what does 20 have to do with anything? Because that's 48. What does 20 have to do with anything? Where does 20 come from? I know that point happens to be the 20th percentile, but what does 20 mean? There you go. And that's precisely the purpose behind this exercise. What 20 means, when somebody says 20th percentile is 48, what that means is if you connect this 48 straight up to the curve, and then if you shade everything to the left, and it's always to the left, and it's always to the left, if you shade the area to the left, and make it a little thicker, if you shade the area to the left on this distribution under the curve, make it a little smaller. So if I shade the area, that area here, that's 20%. There you go. That's what this thing is trying to tell you. So basically, when someone says the 20th percentile is 48 under a bell-shaped curve, it means that 20% of the students had grades that were below 48. That's what it means. Which obviously you can get a free information here, because we always know that in probability, the whole thing in statistics is always a what? Absolutely correct, is 100%. So if the bottom tail of it is 20%, and somebody turns around and says, okay, well, can you tell me what percentage of students are getting grades above 48? And that'll be easy to calculate, because the whole thing is 100. This is 20. So obviously this part would be what? Very good. So basically you could say 80% of my students got grades above 48. And above in a normal distribution is always to the right. Below is always to the left. And that's number 26.